infinity with horizontal asymptotes. So we just learned our tricks here for horizontal asymptotes. We're going to create an equation. Call this example 1, x squared. We'll say the value is 5. X squared minus x plus 2 divided by 10. X squared minus 6x minus 5. Okay. According to our trick, what is the horizontal asymptote going to be? What is it? 1/2, 0.5, right? We found our degrees on the top and the bottom, numerator and denominator happen to be the same, so we took the coefficients. And their ratio, well, their ratio is 5/10, which is also the equivalent of 1/2 or 0.5. So our horizontal asymptote is going to be, that's a 2. That's supposed to be a 5. Sometimes I say things, but I don't write them. Okay, so if 0.5 is a horizontal asymptote, that's great. Now what we're going to be doing is I should have made an easier function. Oh well. Here's our original function, our f at x. To test when our limit is tending to positive infinity, we're going to take an extremely large positive value. We could say 10,000. Positive 10,000. And we're going to take that value for x and plug it in to our original equation. We're going to do the same process as x tends to negative infinity. We're going to take an extremely large negative value. It could be the same magnitude or the same value, 10,000, but it doesn't have to be. So let's use negative 5,000. These are still very large negative and positive values for x. We're going to take these values, plug them into the original equation. If f at x is greater, that's not greater. If f at x is greater than our 1/2, that means we're approaching from above. Okay, so it's coming from above. And if your f at x, when you solve, when plugging in these values, are less than 1/2, it's approaching from below. And when I mean below, when I mean above and below, I mean the horizontal asymptote. Okay, so let's plug these in. F at positive 10,000. Now I could factor this and make it possibly a little easier, but we do have calculators these days, so let's just use that. Minus 10,000 plus 2 divided by, as I type this in, someone wouldn't mind trying to solve it on a calculator. Oh, 10,000 is such a large number. Okay, let's see if we can get this. 10,000 squared times 5 minus 10,000 plus 2. I think it's 499 million. Is that right? 499 million? So I'm going to say 499 million. I got to look at that again. Clearly chose a number. I wish I had a comma calculator. 990,002. Yeah, okay. 990,002. That's the top of this. The bottom, same idea. 10,000 squared times 10. Subtract 60,000 minus 5. $939,939,939. What was the last two values there? Thank you. 995. Okay. If you guys look, this is very close to possibly 1/2, right? And that was our horizontal asymptote. And it makes sense because the farther along x we go, the closer we get to the asymptote without touching it. So we're about to find a value. Hopefully my calculator doesn't round. 499,990,002 divided by 2, 3, 4, 1, 2, 3.5. Larger or smaller than a half? Larger. It's very, very close, but it is larger. So, since this value, f at positive 10,000, or as x tends to positive infinity, is larger than our half, that means our horizontal asymptote at a half, it's approaching it from above. So in other words, it's coming at it like this. Okay? You would do the exact same thing with the negative value we chose, negative 5,000. I'm going to go on the assumption it ends up being less. And if it's less than a half, then it ends up being... So this is hypothetical. I haven't proven it. But if it was less than a half, it means as it tends to negative infinity, so that's heading towards the left, it's coming from below. Okay. And just because, I know this happened to work out, just because positive happened to be from above, it doesn't always. We could have plugged in a positive value and actually got less than our horizontal asymptote, and we still would have headed to the right, but just approached that asymptote from the bottom. Okay? And then the other would be vice versa true. If our negative value, so as we approach negative infinity, happened to be larger than a horizontal asymptote, then we would have approached negative infinity or tended towards it from above. So that's what they talk about when approaching a horizontal asymptote from below or above.